Hello everybody, welcome to the practice problem video for exponential and log equations day 2, so technically section 10.6. Let's start here with number 1, which is an exponential equation. And so again, the first thing I would consider when you're looking at an exponential equation is to see if these two bases can become the same base. So if we look at 16 and 64, is there any number that we can raise to a power for both 16 and 64? Well, actually, there's two. You could either do 2 to the something for both of them, or you could do 4 to the something. I'm going to use 4 because the exponents would be smaller that way. 16 is the same as 4 squared. And then the 2n minus 2 is still in the numerator, so these two exponents are going to multiply. And on this side, 64 is the same as 4 to the third, and then the exponent of negative 2n minus 2 is also still there, and those exponents are going to multiply. So again, because these bases are the same, these exponents are now equivalent or equal. So 2 times 2n minus 2 is equal to 3 times negative 2n minus 2. 4n minus 4 is equal to negative 6n minus 6. Add the variables over. 10n minus 4 equals negative 6 plus 4. 10n equals negative 2. Divide by 10. The answer in exact form would be negative 2/10, or the best answer, negative 1/5. Number 2, also exponential. So think about if you can change both of these bases to be the same thing. Can you do the same thing as number 1? Well, 5 to the first is 5, 5 to the second is 25, 5 to the third is 125. So we skip right over 77. So these do not seem like they could be written as the same base. So when we can't do that, we remember that exponents and logs are inverses and that logs are exponents. So we can change the formatting of this to be a log or ln equation. So again, I tend to either use log or ln. In the notes video, I used ln, so this video I'll use log, but it does not matter which one you use. So let's say you apply log base 10 on both sides. You could also do log base 5 if you'd like to. That would work as well. But these two are kind of like the most versatile logs that you could use for any situation. So log of 77. Now that we applied log on both sides, the exponent would come down in front. So you have v times log of 5 equals log of 77. And then you would divide both sides by log of 5. So you have v equaling in exact form log of 77 over log of 5, which is absolutely the correct answer. But if you would like to also write your answer as a decimal, because sometimes I will ask you to do so, x would be 2.699 if you rounded to the nearest thousandth. Originally it's x equals 2.6989, but you'd make sure to round the 8 up to a 9. Number 3, this one I like. You have log base 10 on both sides. That means that the arguments are equal. So all you have to do on this one is x squared minus 27 equaling x plus 3. And then we'd have to factor. So we'd have to move these over here. So x squared minus x, subtract the 3, minus 30 equals 0. Does this factor? Well, this is really negative 1. Two numbers that multiply to be negative 30 and add to be negative 1, that would be negative 6 plus 5. That means my two hypothetical answers are 6 and negative 5. However, if I plug negative 5 into especially this piece, I'm going to get a log of a negative number, which is impossible. So my only answer is x equals 6. If you would like to make sure that this works, it would be log of 36 minus 27. Is that equal to log of 6 plus 3? So you would get log of 9 on this side equals log of 9 on this side. Check. 6 works. Number 4. Some of these you might notice are mixed from the first day of log equations as well, because I want to keep things cumulative, of course. If we take a look at number 4, this is originally a log equation, and the best way to solve a log equation is to see if you can change it to an exponential equation. So in this log, the base is 9. In this log, the exponents, logs are exponents. The exponent's negative 2, and it equals the argument of x. So x equals 9 to the negative second, which is the same as, remember 9 to the second is 81, so the negative exponent causes the reciprocal. 1 over 9 squared, or the best answer, 1 over 81. And when your answer is a decent fraction like that, you do not need to necessarily change it into a decimal. The only time I tend to change things into decimals is a problem like number 2, where we have answers in terms of logs. So you're going to notice I'm going to ask for exact form a lot for these. Number 5, I would say is similar to the one we just did. So we want to get log by itself. And so the first thing we need to do is get rid of this 5. So the 5 is multiplying, so we divide both sides by 5. So we have log of v plus 4 equals 2. Now again, we have a log equation, and the best way to solve a log equation is to change it into an exponential equation. So the base of this log this time is 10. There's a hidden 10 there. So the base is 10, the exponent is to the second power, equals the argument of v plus 4. So you have 100 equals v plus 4, so v would be 96. And of course, you could take 96 and plug it back into the original to see if it works, just in case. Log of 96 plus 4, so log of 100 equals 10. Well, is this true? I don't even need my calculator, actually. Here's why. This piece, log base 10 of 100, logs are exponents. So the exponent to make this true, 10 to the what is 100? 2. 10 to the second. Then you take that 2, multiply it by 5, so you get 10 equaling 10. Check. 96 is the answer. Number 6, this time your equation is exponential, and so you might need to change it to logs. Before we decide that, we need to isolate what is exponential. So 12 to the power is the only exponential part. So we need to get that by itself. So first thing we need to do is get rid of that 9. 3 times 12 to the r minus 4 equals 69. And I'd say a very common mistake here is for students to think that you should multiply the 3 times the 12. But the 12 is not a regular number. You're not multiplying these. It's 3 times the base of 12 to the power. So we still need to isolate this exponential piece. So we need to actually get rid of that 3. So just like number 5, we need to divide both sides by the number in front. So we have 12 to the r minus 4 power equals 69 divided by 3, which is 23. And now that we have this situation, we need to think about if we can change the base to be the same, or if we have to go from exponentials to logs. So let's think about it. 12 to the first is 12. 12 to the second is 144. So we skip over 23. Nothing to a power equals 12, and nothing to a power equals 23. So that means that we need to change this equation to be exponents to logs. So this time what I'm going to do, on the previous example, number 2, I used log, so now I will use ln. So I'm going to apply ln on both sides of my equation. You could, and the reason I would avoid log base 12 or log base 23 is because we have 2 separate bases this time. So now that we applied the log, the exponent can come down in front. So we have r minus 4 all multiplied by ln of 12 equals ln of 23. So if my goal is to continue getting the variable by itself, I would suggest instead of distributing the ln of 12, I would just get rid of the ln of 12 because it is multiplying all of this. I would move that to the other side. See you later on the left. R minus 4 equals ln of 23 over ln of 12. And so the only thing I have left to do this time is add 4 on both sides. We have nothing to divide like the notes. So our final answer in exact form is r equals ln of 23 over ln of 12 plus 4. But sometimes I will ask you to write this as a decimal. And so if you take ln of 23 divided by ln of 12 in the calculator, you get 1.262, add 4. So your final answer to the nearest thousandth would be 5.262 if you round to the nearest thousandth. Please again check to see that you're getting the same answer. Number 7. So now we have multiple logs happening here. This is more similar to the video you just watched. So when we have 2 logs of the same base on the same side, let's make this into a single log. Log base 5. The properties state that if you have 2 logs separately being added, the arguments are really being added. X times 6 equals log base 5 of 3. And now because we have log base 5 on both sides, the arguments are equal. So x times 6, or 6x, equals 3. So all you have to do is divide by 6. So x would be 1/2. Number 8, we have two logs on the same side again. This time they're being subtracted. So if I make them into a single log, log base 3, this time the arguments are going to be divided. X plus 2 over x equals 4. Now this time we can't set something equal to something right away because we do not have logs on both sides. So instead what we need to think about is that we need to change this log to an exponential equation because again we don't have log base 3 on both sides. The base of this log is 3, the exponent is 4, and that is going to equal x plus 2 over x. 3 to the 4th is really 81, so this is really 81 over 1 equals x plus 2 over x. Because we have a fraction equaling a fraction, we can cross multiply here. So we have 81 times x equals 1 times x plus 2. You would subtract the x over and get 80x equals 2. Doesn't seem like it's going to be that bad of an answer, because if I divide both sides by 80, you're going to get x equals 2 over 80, which could be reduced to a decent 1/40. And just like the log equations, guys, these are log equations, just like the earlier ones, you could take 1/2 and plug it in, and you could take 1/40 and plug it in. And if you do, you should get both sides of this equaling 4, and for this side, you should get the same number on both. The answers do work. Last two problems, also using the expanding or the condensing idea of logs. You have two separate logs this time, and it is log base 10. They are being added. So you can make it into a single log of log base 10 of x plus 3 times x plus 24 equals 2. If I simplify that and I FOIL, that would be x squared plus 24x plus 3x plus 72 equals 2. Log base 10 of x squared plus 27x plus 72 equals 2. So, again, unlike number 7, where we had a log equaling a log, we could say the arguments are equal. I would say this is more similar to number 8, that we have log equaling an exponent. So we can change this from a log equation to an exponential equation. So that would be base 10 raised to the exponent of 2 equals x squared plus 27x plus 72. So that would be 100 equals x squared plus 27x plus 72. Or if we would like to factor this, or try to, we move the 100 over to the other side. We would get x squared plus 27x minus 28 equals 0. This does factor. 28 times 1, positive 28, negative 1 gives me 27, and multiplies to negative 28. So my two possible answers are x equals negative 28 and x equals 1. But as we've discussed, we cannot have a domain of a negative number. And if I tried to take negative 28 and plug it back into my original, I would have log of a negative, which is not possible in the domain. So my only answer is x equals 1. And of course, you could always take 1, plug it in to the original equation. If you do, you should get both sides equaling 2. Last but not least, number 10, we have ln of two different ln's being subtracted, which is the same as a single ln of these two logs, or the arguments being divided. 6 over 2x equals 5. So in a similar way to number 9, we do not have log equaling log, so we need to change this from a log equation, or ln, to an exponential equation. So this time, the reason I put both of these next to each other is to show you the difference. If you see log without a base, you assume it's 10. If you see ln without a base, you assume the base is e. So if you want to change this to an exponential, the base is e, the exponent is to the 5th, equals 6 over 2x. So this is really e to the 5th over 1 equals 6 over 2x. Now that you have a fraction equaling a fraction, you can cross multiply. So we'd have 2x times e to the 5th equals 6. Okay. And so then, if you want to solve for x, the first thing I would do is get rid of the number e to the fifth. So you'd have 2x equaling 6 over e to the fifth power. And then you're going to have to divide by 2. Now, something that might help you here is remembering that dividing by 2 is the same as multiplying by 1/2. So then these 2's cross out. You have x equaling 6 over 2 times e to the fifth power. But if you looked at the answer key attached to this worksheet, you might have noticed that this answer does not match yet. That's because these can be reduced to be 3 over 1. So the best answer is just x equals 3 on the top and e to the fifth on the bottom. Technically it's 1 e to the fifth, but you don't need the 1. Alright guys, this is the end of the video. Hope it was helpful. Come visit me, contact me if you need extra help. Thanks.